So composition versus inheritance. Inheritance is a relationship where you've got a class or an interface, usually a class that has some common behavior, and you've got other classes that extend that behavior. Now that's usually fine if you own the entire hierarchy and you know how everything works and you know that you're not going to make any mistakes. So you extend other classes and you benefit from not having to duplicate code. But it's not the only way to do things. So the problem happens usually when a program is so complicated that you forget how certain bits of it work, or you're extending somebody else's class that you don't really know how it works. So in that case, the advice is not to use inheritance in the first place. Just use composition rather than inheritance. So we'll look at an example of that in a second. So inheritance is obviously powerful, but can be dangerous. It's safe to use it within a package. So the hierarchy is under the control of the programmers. And also it's safe when the classes are well documented and designed for extension. But inheritance from classes across package boundaries between packages that you don't necessarily own is a dangerous thing, especially if you don't understand how they work. So it breaks encapsulation. So obviously subclasses depend on the implementation detail of superclasses. So anything that changes in the superclass can break your own classes. So let's have a look at a little example. So this is the collections, a little part of the collections framework. So remember, one of the part of the collections framework is a set, and another interface is something like a sorted set, for example. And one of the implementations of the set, or the main implementation of set, is abstract set. So it holds all the common implementation in there. Below that, you've got a concrete implementation here called hash set. And one of the things that we want to do is we want to create our own implementation of set. This does something slightly extra. So we create our own class. We call it instrumented hash set. So what we want it to do is to keep a count of addition attempts to the set. So whenever somebody tries to add an element to the set, I'll just want to keep a count of that. Okay? So I'm not looking at necessarily successful additions to the set. I just want to keep a record of the attempts to a set. So I've created my own concrete implementation. So here's what it looks like. But it has a problem, so we'll try and figure out what the problem is. So I've got a class, and I've called it instrumented hash set, extends hash set. So this is the variable that I want to keep a record of, add count. So how many times somebody tries to add something to a set. So if I'm extending the set, then the hash set, then all I want to do is add my new behavior to it. So whenever somebody tries to add an element to the set, I just say add count increase by 1. And then I want to return super.add, because obviously hash set already implements add, so there's no need to duplicate any of that code. So you say super.add, and you make use of that code. Same thing with add all. So if you want to add a bunch of elements to your set, then add count is equal to add count plus however many elements I want to try and add. So this C here, dot size will give me how many elements I want to try to add to the set. Okay, and then so I maintain a record of that in my add count variable. It should increase it proportionally to how many elements I want to add. And then there's no need for me to re-implement add all. I just reuse the add all method from the super class. So I just call super.addAll. Okay, so have a look at that and try and think of what could go wrong. Okay, so let's try and run this and see what goes wrong. Okay. So this is my class, instrumented hash set, extends hash set. So it's the same as what we saw on the slide. It's got some additional methods just to make it work. So I've got my add here with an add count incrementer, and I've got an add all with an incrementer as well, calling super.addAll. And here I'm trying. This is my class that uses that. So I'm just going to comment this out, which is the correct solution. I'm going to run this. Use instrumented hash set. So I'm creating an object, instrumented hash set s is equal to new instrumented hash set, which takes strings. So I'm adding the element beep to it, for example, just as a little test, getting the size of it. And then I'm trying to add a number of different elements. So s.addAll, so snap, crackle, and pop. And then it should, so how many elements should there be there in total after you add those beep, snap, crackle and pop? Should be 4 elements. So if we try and run it, okay, so what's happened is initially we added a beep, so we ended up with the add count being 1, then we added 3 more elements and the size should be 4, but the add count gave us 7. So the way the add all method works is that obviously to make it work, it's calling the add method. It's not calling the add method within the extended class, it's calling the add method of the actual class itself. So when you're running add all, it's running this add. So the count is happening twice. Okay, so this is an example of a bug which you might not notice if you're using inheritance. Okay, so that's why you only do inheritance if you know exactly what's going on within your architecture, within even somebody else's architecture. That's why inheritance is discouraged, and the solution is, in this case, is not to use inheritance at all. Actually, it's actually better to use composition. So instead of having my instrumented hash set class, I create something called an instrumented set, which doesn't inherit from anything. All it does is that it uses this this set hierarchy. It just uses it. Okay, so it just creates an object of type set and just uses it. It uses all of its methods and all its capabilities rather than inheriting for it. There's no need for inheritance in this type of thing. So what you do is I have a class. So this is the correct implementation. I have a class instrumented set. So it implements set, which is fine. So it does implement set, but it doesn't extend from hash set. Okay, so we're using interface inheritance, not class inheritance. So it's okay so you're implementing set to acquire its type, but later on when it actually comes to creating the object, you create a physical object within the class itself. So I declare an object of type set within my class. Okay, and I've got my add count calculator. So if you look at the previous example, you're not actually using anything here. You just have your add count. So what we do is, so you create an object of type set in here, and you override the add method as you should because you're implementing set. Remember, if you want to create your own class of a particular type, implement the interface of it so you can acquire the type. Okay. So you create our add method. We do our add count plus to increase the number of elements. And then what you're doing is you're returning s.add. So you're not using the super keyword. There's no concept of a super class in this case because you're not inheriting from anywhere. It's this s here. It's a completely different object. Okay, so it's not the same object as the one that you're working on. The same with add all. So you do your add count, so you get the size of whatever data structure you want to add to your own set, and then you return s.addAll. So basically you're using the capabilities of the hierarchy rather than being part of the hierarchy itself. So that's what composition is. You're just using something rather than being part of it. Okay, so if we do it using composition and we try to run the same example, I'll comment that out and I'll use my instrumented set instead. So we're doing the same thing. We're trying to do the same thing. Actually, we're adding just 3 elements here. So yeah, so you've added 3 elements and the add count is 3 in this case. So yeah, so only use implementation inheritance when there's a genuine relationship between classes. Even then, be careful when inheriting across package boundaries. So you end up with a strong binding to superclass implementation detail and release of fragility. So if you're going to do inheritance in its fullest form, then you need to understand everything within the classes that you're inheriting from and how things are working. It's very easy to introduce bugs that you're not aware of. So there are good coding practices that you can follow to limit that. So don't use it just to acquire behavior. Generally speaking, composition is more robust. So obviously wrapped implementations are encapsulated and can be replaced. So what you can do using composition, because we just used the set type within our instrumented set class, we can easily remove that, take it out, and use another that can do things better than a set, for example. So composition is not tied to the single inheritance type hierarchy and is more powerful than subclassing. it obviously supports selection of required behaviour.